And of course, you can take advantage of trusted third-party solutions from providers that you may already be using. But here's the thing, it's not all on us. Really, you need to be thinking about security best practices from the start. And I can tell you some really sad stories from my time. Here's just an example right here. You really do not want to try and retrofit security into your application after you've already had a breach. You are risking reputational damage with your customers, with your colleagues, with your employer. It is so much cheaper and easier to move security to the beginning of the process. And so lucky for you, we are here to help. And I want to start off with some underlying basic security principles that you need to know, the most important of which, of course, is our shared responsibility model. I'm sure you've seen this before. But what I really love about this model is how it makes it clear that security is a layered approach. The stuff at the bottom in orange, that's what AWS is responsible for, the security of the cloud. And that includes the physical infrastructure, the facilities, the actual compute building blocks. So we employ the same security isolations as you would see in traditional data centers. That includes physical data center security, separation of networks, isolation of hardware and storage. And the cool thing is our scale actually allows us to significantly invest more in security policing and countermeasures far beyond what any individual company could do for themselves. Now at the top in the blue, that's what you're responsible for. You're responsible for security in the cloud. That means that you are going to be responsible for securing the workloads and applications that you deploy onto the cloud. You're going to have, of course, access to all of those services that I mentioned. You're going to have flexibility to apply more security measures to parts of your infrastructure than you need than others. And you're going to be able to benefit from all of those security frameworks, compliance frameworks, all the wonderful practices we've put in place to meet some of the strictest security requirements of our customers in the world, regardless of how big or small you are. So it's not all on us. You have to do your part as well. And so let's talk about some security principles here. Really, what it comes down to with security is who can access what. And that who could be a user, it could be a developer who wants to launch Elastic Compute Cloud instances, that's EC2 as we call it. Maybe it is actually an application, that could actually be the who, that actually wants to access S3 buckets, our simple storage service buckets. So this actually requires two roles to make this happen. Like first is on the permission side. You actually have to define that policy of who can access what, but it's on AWS's side. It's our job to actually enforce that policy. And we use a service called IAM, Identity and Access Management, that's mostly responsible for ensuring that that happens. And so that's our part to actually make sure that if you say user or application X can only talk to resource Y, that X can talk to Y, that nobody else can talk to Y based on what you've specified in your policy. And there is actually a name for this. This is called the principle of least privilege. Maybe you've heard of this one before. And unfortunately, this isn't just a tick box or a service that you can turn on. This is a mindset that you need to develop whenever you think about security. And what it means is that you're only granting a resource, whether that is a person, a piece of code, or an AWS service, only the absolute minimum access they need to perform their job. And look, it would be really easy to just give everybody and everything super user access, right? That would make my job and your job so much easier. We would never have to deal with anyone coming to us and saying, I can't access this thing that I need. But that's really dangerous. Think about what that means. Anybody could do anything in your infrastructure, including covering their tracks for changes they've made. So you really don't want to do that. Now, of course, this can be tricky to figure out what that level of permissions should be to give someone just the minimum permissions they need to do their job without introducing, unnecessary friction. And we do have tools that can help you with this, like the IAM Access Analyzer. But really, I just want you to keep this principle in mind. Least privilege is a goal that you should be thinking about working for. It's a continuous goal that you should have as you think about security for the rest of the day. All right, now if you've just signed up for your AWS account, perhaps you're brand new to AWS, I'm going to give you some very simple steps that you can take today to help make your account more secure. And if you're a more experienced user, hopefully none of this will be new to you, but I cannot tell you the number of times experienced users have missed one of these steps. So hopefully today everyone's going to find something they can do, practical tips to make your workloads and your account more secure. The first one, Very simple, is making sure your account level contacts are set up. Look, when you have something go wrong, whether that is a security incident, whether that is your credit card expiring, you want AWS to be able to contact you quickly so that it can get resolved. And you would not believe the number of people who don't have their contacts in their account up to date. So please go into the console, go into your accounts, and make sure that they're accurate and that they're set up correctly. You actually also have billing, operations, and security contacts as well, so you can have separate contacts for each of those. You've got no excuse after today not to have these up to date. Now, though some of you more experienced users might have multiple accounts, if you're following a multi-account strategy, and you might be thinking, Chris, this is going to be such a headache to actually update all these. We actually do have a solution to make managing this a little bit easier. A few years back, we introduced a new feature in AWS organizations that allow you to programmatically manage the account level contacts. So you can access this within the console. You can actually do it via API. And we actually have a really good blog post up that is actually going to walk you through, just using some simple Python, how you can update all of these contacts across your accounts programmatically. So look that up if you need it. All right, pro tips related to this, okay? Just a few things I've seen people do wrong. First is use a company domain name in that email address, not a personal email address. Like, you might have signed up for a personal account just to try things out, play with some services, and that's fine. But if you're gonna have workloads that go into production, if you're building a business, use a company domain name in that email address. And why do we say this? Well, look, employees leave, they move around, and you do not want important company assets like your AWS account in the hands of someone that you can't actually access anymore because they've left. Along with that, it's a really good practice to actually use mailing lists instead of individual email addresses in those contacts. So instead of setting up a single person for finance alerts, set up finance@yourdomain.com, set up security@yourdomain.com, and actually have that go to a number of people instead of just a single point of failure. So just an expert tip for you there. All right, let's talk about the root user. The root user is created when you first created your AWS account. It's got privileges and permissions over the entire account that can't be changed. And here's the thing, if you are logging in to your account via the root user, stop it, okay? If you do nothing else today, make sure you break yourself of this habit. Stop logging in as the root user for this account, even if you are the only person using that account. Instead, what we want to do is we want to secure that account. I want you to go in and put a really strong password on it, and we'll talk about what that looks like. I want you to turn on multi-factor authentication, or MFA, and then you're going to remove the access keys, actually delete the access keys for that root user. So instead, how you're going to avoid this is you're going to set up an IAM user, IAM users and groups, and we'll talk about that for your day-to-day use of the account. Look, there's really actually only a few use cases that you need that root user for. Things like setting up your support levels or deleting the account. For everything else, you shouldn't be touching it, okay? So again, set up a password policy, use MFA for all your IAM users, and really break yourself of the habit of using that root account. Now, sometimes you do need to have access to that account, and I know people in the past have talked about printing out those credentials, maybe putting them on the wall for key users. The pandemic sort of really accelerated the move to remote teams, so that may not be possible for you. So instead, what we recommend here is if you do need to share those credentials with key users, is actually to use a modern third-party password managers. Because some of them even have break glass provisions. They can allow you to store and share the MFA token that's associated with that root account. But just remember that principle of least privilege. Just because you can share these credentials, you don't want to share them with everyone, only with the key people who may actually need access to that root account. So how do you give people access to the console? I sort of talked about this. Best practice is to use IAM users. These are temporary credentials. That means they're you don't have to go in and rotate them yourselves. You don't have to revoke access. Instead, you set up IAM users, but here's what not to do. Don't set up a single developer's user and share those credentials with all the entire dev team. Because think about that. How do you actually revoke access for one person if they leave? How do you actually distinguish, for auditing purposes, what one developer did versus another? It gets really tricky. So instead, what you should do is set up a developers group in IAM, and then you're going to assign individual users to that group, and the group is the one that has the permissions. So this is really what's great when you're getting started out. If you're a more advanced user, the sort of next level, what we really recommend is federating users from a centralized identity provider. And you can use AWS IAM Identity Center, what used to be called a single sign-on for this, but we also support third-party identity providers like G Suite or Okta or Active Directory. And so federating users really allows you to manage all of those identities in one place, all of their permission authentication, and they just log in with one set of credentials and they can access a number of resources, including AWS. You also, I mentioned, want to really enforce a strong password policy. And so what's shown here in the screenshot is what's recommended by the Center for Internet Security. That is their strong password criteria they recommend, including that you set the password to expire every 365 days, or of course, if there is an incident, you want to actually, for any suspected compromise, you want to rotate those passwords as well. I really recommend you tick the box to allow users to reset the passwords themselves. That's going to save you from an administrative nightmare. And of course, you can change this policy in the console really easily. Let's talk about logging events now in your account. What's happening? We have a service called AWS CloudTrail. This is a service that is automatically, by default, logging all the API access in your account for 90 days. And so that applies to both API calls, but also actions you take in the console via the command line interface. All of that's going to be logged for 90 days. Now, you may want to actually extend that, and you can do that by actually setting up a new CloudTrail and sending those logs to an Amazon S3 bucket. That's going to allow you to store logs beyond those 90 days. It's really easy to set up. Within 15 minutes, you can have those CloudTrail logs being saved. Just again, principle of least privilege, make sure that that bucket is locked down to just the people who need to access it. Turn on MFA for it, turn on versioning to make sure it doesn't automatically get deleted. Just make sure that you're securing that bucket just to the people who need to access those logs. All right, I talked about S3 buckets. I know S3 buckets are a source of a lot of questions with regards to security for people, because after all, S3 buckets are simple storage service. They can hold all different types of data and objects. You could store your CloudTrail logs in there. You could also be serving your website out of an S3 bucket. Maybe you've got really, business critical data or sensitive customer data in there. You do not want that to get public. There are very few times when you do want an S3 bucket to be publicly accessible, mainly when you're serving a website. For the other cases where we see this, it's usually a result of misconfiguration. So to protect against this, we're trying to help. We introduced a feature called S3 Block Public Access. And this is a set of 4 security controls that are going to override the settings that would have allowed that bucket to accidentally be turned on to the public. It's super easy to access this. I'll show you what it looks like. But actually, it's even easier because any buckets created, I think since the end of February, actually have this turned on by default. So you don't even have to worry about it. But for any other buckets, if you do need to turn on S3 Block Public Access, it's just a couple of clicks in the console. So you really got no excuse for having a bucket with this risk of going public. One more thing about S3 buckets and CloudTrail. I mentioned that CloudTrail is going to be logging all the API calls. It's logging events, management events in your account. So events that actually create, modify, or destroy resources. However, CloudTrail by default is not actually capturing read or write operations on individual objects in S3 buckets. And this becomes an issue, if you do have an intrusion, if you do have, a suspected security incident there, you're going to want to know who's accessed the data, the objects in your buckets, if anyone has. And so for that, if you have buckets with sensitive data in it, it is best practice to actually set up a CloudTrail. You can actually set up CloudTrail to actually record those events. So you can actually record events on those buckets. So we have blog posts that show you how to do this. It's really easy to do. And just one last thing, when you're looking at the services that you're going to be using to build your applications, I really want you to consider from the start using managed and serverless services. Imagine if all you have to think about is your code and AWS is taking care of the rest for you. That's really what I mean by this. When you take advantage of services like AWS S3, of DynamoDB, of AWS Lambda, you're actually pushing those security requirements, those compliance requirements onto AWS. And you remember that shared responsibility model that we talked about, that dividing line of what AWS is responsible for and what you're responsible for. When you move to the right on this diagram, when you use those managed and serverless services, you're actually moving that line up a little bit higher. You're taking less of that onerous task on yourself and pushing it onto us. So really consider the services that you're looking at. Speaking of services, all right, let's recap. I've covered some fundamentals. I talked about the shared responsibility model. I talked about the principle of least privilege. We went through some very simple, half a dozen very simple steps you can take today to secure your AWS account and think about security of the applications that you're building. I do want to talk you through just a few of the services we have that can make your life easier in terms of detecting when incidents happen and helping you remediate them. So just a couple of them. The first is an unusual one you might not think of, is AWS budgets. This can actually be a really useful tool because if all else fails, sometimes monitoring your costs can be an indication of unexpected activity. For example, if you see a huge spike in outbound data transfer for your account, if you see a jump in EC2 instances, EC2 costs, that can be an indication that something's gone very wrong in your account. I actually use AWS to host some personal sites. I know what my monthly costs roughly are, and so I've actually set up some budgets for myself. I've got one that triggers at 50% of my costs, I've got one that triggers at 100%, and I've got one that triggers at 200%. And if I trip any of those, it sends me an email earlier in the month than I expect to. I know that's a sign I need to investigate. And so we have a number of blog posts that walk you through setting up a budget. You can even pipe those alerts into a chat bot, into Slack, depending on what your team uses. Along with that, I also want to call out AWS Cost Anomaly Detector. This is a service that only came out a few years ago, and it uses machine learning to watch your account for unusual spending. And that also can generate alerts via email, via Slack. And what I really like about this service is it doesn't just tell you when something weird happens, it actually tries to point you to the root cause of that spend. And as of a few months ago, this is actually available to all Cost Explorer users, the default configuration. So have a look in Cost Explorer and have a look at the documentation to see how you can set up alerts from Cost Anomaly Detector. Guard Duty is a service that I really recommend you check out as well. What is Guard Duty? Guard Duty is a threat detection service that is continuously monitoring your AWS environment, learning from it to detect vulnerabilities, to detect unusual and malicious activity. So it's going to look across all your AWS accounts, your databases, your container workloads, your S3 buckets, and it's going to be looking for potential threats to help you remediate them quickly. So how does that actually work? Well, it takes a number of different data sources here, things like VPC flow logs, DNS logs, those CloudTrail events we mentioned, S3 data plane events, and it's going to actually look for really common patterns of intrusion, things like Bitcoin mining, backdoor command and control activity. It's going to be looking for SSH brute force attacks. Also looking at things like resource provisioning in a region where things don't necessarily spin up usually, unusual traffic patterns, things like that. And as you grow, Guard Duty can actually provide the foundation for a really sophisticated security architecture where you can start building in really cool automations that do things like automated remediation or even isolating, suspected compromised resources. There's a 30-day free trial on this. Please check it out. It is a regional service. And so I highly recommend if you are going to turn this on, see what it looks like in your account, turn it on in all regions, not just the ones where you're operating, because after all, you want it to have the opportunity to look for resources spinning up in regions that you aren't looking at on a daily basis. And also if you're using EKS, Elastic Kubernetes Service, or S3, there are special, you can actually turn on special checking just for those services. And again, the Guard Duty user documentation does a really good job of walking you through how you set this up and how you configure those alerts. And the last service I want to mention is Trusted Advisor. This is a free tool that proactively scans your environment for issues around cost optimization, resource limits, a number of different areas, but also security. Okay, and for basic and developer support levels, all you do is go into the console, go to Trusted Advisor, and refresh these checks. You get 6 security checks. You get about 50 resource limits it's going to check, and those security checks map really nicely onto those basic steps I told you, things like securing the root account using MFA, security of S3 buckets. And if you're on a higher level of support, you get access to the full suite of more than 115 trusted advisor checks, and you can configure to have those alerts sent to your email, to your Slack regularly. So definitely check out Trusted Advisor. I have run through just a few services of AWS's foundational and multi-layered security services. We have a lot here. If you are familiar with the National Institute of Standards and Technology, the NIST cybersecurity framework, this is how they map to the areas of focus to identify, protect, detect, respond, and restore your environment. So I've only touched on a few of these. If you want to go really deep on security, I highly suggest you check out our recent AWS Reinforce conference. This took place just a month ago. It is an entire event dedicated to security. And the wonderful thing is if you go to the website here, you see that Watch Now button in the upper right. The keynotes and the breakout sessions are available online for you to watch. So if you want to go deep on any of these security topics, go check out Reinforce. Now, it's one thing to learn about security services in a vacuum. I always love to give a customer example. One customer I wanted to talk about today is RazorPay. So RazorPay is a payment provider, a payment solution in India that make it really easy for businesses, for retail businesses to accept payments, from credit cards, from net banking, from popular wallets. And they do this via B2B model, via API, where merchants can actually call an API to submit a payment request. And of course, this architecture, this business model makes them really vulnerable to DDoS attacks, to distributed denial of service attacks. They need to be able to distinguish between what is legitimate traffic, between small or even very big businesses calling their API, and potentially malicious traffic. And so there's a recent post on the AWS architecture blog that does a really good job of walking you through how RazorPay set up a 2-layer microservice architecture to help guard their API gateway, which is really the critical factor in this architecture. First, they use 2 services I didn't get to today, WAF, Web Application Firewall, and Shield Advanced. And they actually put those services on their application load balancer. And so they're looking at the traffic coming in, and they're able to block and they're able to rate limit those requests that are coming in. And then the requests that do go to their API gateway, they are feeding those events in real time into a time series database, and they're then able to use machine learning to actually analyze those traffic patterns. And based on that, they can take automated action like updating the web application firewall rules to block. They can actually change rate limits on the fly. So definitely go and check out that blog post. All right, I said the magic words. I said machine learning. I can't believe it's taken me nearly half an hour to get to it. It is definitely the hot topic of the day. And what you may not realize is machine learning can actually help you write more secure code today. I'm going to walk you through a service that is going to help you do that. Amazon Code Guru Security is a static application security testing tool that uses machine learning to help you identify vulnerabilities in your code. And not only is it going to identify them, it's actually going to show you how to fix them. It's going to give you recommendations for remediation. It was announced in public preview just last month. I'm pretty sure it was at Reinforce that they announced that. And you can use this to scan Python, Java, JavaScript code. It integrates with a number of popular IDEs, with VS Code, with JetBrains. It works with GitHub, GitLab, a number of different services as well. And so to give you an idea of what it's looking for the OWASP top 10 vulnerabilities, if you're familiar with those, the CWE top 25. It's looking for log injection problems, secrets that you may have accidentally hard-coded, things like that.